Is somebody speaking, or is that I'm not able to hear anything?
Is it okay?
I can hear you, but there's a long period of silence. I'm wondering if somebody is taking the lead or.
No. Basically, when people are unmuted, a lot of disturbance comes, so we mute them. Otherwise, what happens is a lot of background noise it picks up.
Yeah, I could hear some parrots.
Yeah, that's what's nearby. Sometimes, the dogs barking and all these things happening. So, generally, we try to sort of mute the people when the session is on. So, till the session on, so we try to sort of, network with the people, something like what you are doing with Chandramouli, trying to recollect what was
happening. Mutual fund days is a different kind of days. Too much of pressure that time. Yeah. In spite of it being weekly NAV, now daily NAV must be technology also. Yeah.
I still remember the Kothari pioneer, that first
mutual
one of the early people who are in Nungampagam High Road.
Yeah, they're still there. That property is still there.
Property there, but they wound up,
Yeah, they wound up. Yeah, they've started that college in Sri City, no?
Okay.
Yeah, I don't know what is it called. I went and made a presentation there also once.
Okay.
I don't remember what ICMR. Huh? No, not ICMR. Something I don't remember, but their education wing has started that college.
Yeah, that's right. Earlier they had in the Hadas Road.
Hadas Road, correct, exactly. Yeah. The Loyola College,
Loyola College and all this. Rahul was one of the founding person. ICICI, ICICI supported them.
ICICI was a one-floor shop in near Churchgate during the mutual fund days.
Correct.
The beauty is both HDFC and ICICI in the same building. Raman House. And in between, there's only one more floor, Bank of Kuwait in the Middle East. First was HDFC, Bank of Kuwait in the Middle East, and ICICI.
The market is somewhere zooming.
Zooming, sir, but it looks like a lot of retail money has come in from B and C class towns. So, I mean, it's
People without realizing what is likely to happen to
exactly, it's
venture.
become a gamble now.
Yeah, that is, and all the premiums are really unheard of premiums.
And yeah, no. Price to earnings ratio is in your page. You can't make money in the next 10 years.
Correct.
Yeah.
Even investing in mutual fund is also now
The risky
being
amount.
put back because such a high sensex. So even if you apply for the NFOs, so it is not likely to give even 3-4% return also.
Correct.
Doubtful.
Correct.
So I think we, Priya, Akila, can we start? Recording? Yeah. Okay. So I think we'll. Sridhar, would you like to present your this one?
Yeah,
Slides?
I can, but I thought there was somebody going to give a forward. I can go ahead and present.
No. Yeah. I will do the welcome, but you can sort of screen your first slide so that you know.
Yeah, I'll do that. Yeah. Yes, sir. It's come through?
Yeah, it's visible. Yeah.
Yeah.
Yeah, I think we'll start. Good evening, friends. On behalf of the organizing units, Computer Society of India Chennai chapter, ACM Chennai chapter, and IEEE Computer Society Madras chapter, I extend a warm welcome to Mr. Sridhar, our today's speaker, all the delegates who have joined through the Google Meet and also watching through the YouTube streaming, and my colleagues at CSI, ACM, and IEEECS. Today's presentation on demystifying CICD and DevOps by Mr. Sridhar is an introductory module of a longer duration course which is very much in demand for excellent job opportunities. Mr. Sridhar intends to introduce the basics of DevOps, automated testing, code sniffing, continuous integration, and continuous deployment, which form part of software development lifecycle and drawing attention globally. The speaker, Mr. Sridhar, is not new to us. He had already presented a session for us on fintech and payment systems about a year back. However, it is my pleasure to once again to introduce him formally to the audience. Mr. Sridhar is the founder and chief technology officer of Sastra Technologies. He is the architect of the AnyBank platform, which provides portfolio of tools to increase transaction velocity and improve productivity at cooperative banks. His current work focus is on scaling the AnyBank platform and the suite of products which involve 12-factor apps, business process management, enterprise integration patterns, containerization, Docker and Kubernetes, CICD, DevOps, microservices, and services mesh. The AnyBank solution is available on cloud with friendly user interface. It integrates the operations, applying VPN strategies, and automates using RPA. Further, it is a highly scalable solution. Mr. Sridhar enjoys mentoring, coding, provisioning, and helping developers to be successful while building applications using open source technology. With this brief introduction, I would like to hand over the floor to Mr. Sridhar to go ahead with this presentation on demystifying continuous integration and continuous deployment, which is becoming an important topic in software development and which also follows agile methodology to a larger extent. Over to Mr. Sridhar, please.
Yeah, thank you, sir, and good evening once again to all the participants. And as Mohan sir has said, that this particular presentation that I've got for you here is a module based on our experience in developing the product called AnyBank. AnyBank is a platform, so we'll not touch about the commercial aspects of the AnyBank platform. But in terms of the technology side of it, the platform actually consists of a microservices mesh, and it uses the BPM and RPA extensively. Yeah, we don't go with vendors with big names. So we do have BPM and RPA as in its very, native form, or in its non-unbranded form. So I will also show you that. And to get this platform up and running, it has taken us a lot of work in the last 1 year. And this particular presentation is actually a module of all our experiences in actually setting up a CI and CD for that platform. And that's the reason I came to CSI and said, look, I've got this learnings from my experience. I would like to present it to a wider audience. And thanks to CSI and Mr. Mohan sir, they've all given me this opportunity to present it in front of you. And they've also sent me about half a dozen questions that each one of you had. I will answer it during the course of the presentation, but if you're not able to catch it, I'm going to summarize it again at the end of the questions, at the end of the session. And if you still have further questions, you can still ask me. So with that, what I will do is I'll first start with what continuous integration and continuous deployment is. Then I will talk about what are the technology stack that you need to actually implement a continuous integration and a continuous deployment scenario. And it can be implemented in however small scale that you like, or if you like to have a larger scale, I mean, you can have it on multiple servers and things like that. So we will look at all of that during the course of the presentation. Now with this, what is the first thing that we need in deploying a CI and CD? Now, before we get into what we need for a CI and CD, we need to understand what CI and CD is in the first place. Now, when you say continuous integration and continuous deployment, it means that software is developed and deployed like in an assembly line. I mean, when I say like in an assembly line, think of making trucks or cars where the assembly line continuously happens, and each mechanic on either side of that assembly line keeps on adding his bit or doing certain activities on that, on that pipeline, so that at the end, you get a finished product. So CI and CD essentially aims to do that. It doesn't kind of wait for anybody or doesn't stop unless it encounters an error. Now, what happens in this? Okay, now CI and CD can be implemented only if all the players or all the people in the project know that they have to be delivering something which is there in the job description. For example, you wouldn't want somebody who is there writing source code to go and do something else, because when such is the case, the pipeline actually comes to a grinding halt. Now, before we get into that and see how each of these people can contribute, we will see what is the first thing that we need to implement CI/CD. Now, let's say we have a small project. Okay, we're developing something. Let's say we're developing an e-commerce site, or for that matter, a small CRM. The first thing that you need is a place wherein the source code is available. Now, source code meaning the source code should be stored in a place which is authoritative. That is, there should be no question on whether this source code is the latest one or it is given by somebody which is actually 2 months old. So for this to happen, we need a source code to be put in one of the source code management systems. So there are about 5 that I've listed here. There could be others, but predominantly the characteristics that are required of a source code management system is that it has to be distributed, which means that you need to have an authoritative repository on the cloud, and each individual working on portions of the code should be able to get the entire copy of the source code, so that whatever he writes, he can test on his local machine to see whether it works with the whole. I mean, that's one of the essential characteristics or essential features of CICD. And without a distributed source code management, it's very difficult to achieve a CI and CD concept in the project. So we have the most popular one, Git. If you take most projects that are there on open source or that have implemented CI/CD, they would be using Git. Some people use GitHub, which is the hosted solution based on Git. GitHub is different from Git because Git is the original piece of software that is written by Linux. But GitHub is a hosted solution which has got a lot of other commercial stuff built around it. So there are some projects that also use GitHub. Then there's GitLab, which is again a hosted solution. Okay, similar to GitHub with a lot more bells and whistles built around it. The fourth one is Bitbucket, a different form of Git, again a hosted solution. Or you could use Amazon's Code Commit, which is also hosted and is also managed by Amazon teams for a price, of course, as one of the distributed source code management systems. Now, once you have a distributed source code management system, that's essentially the first step. And without a distributed management source code management system, it's very difficult to actually achieve CI and CD, because it's very difficult for a developer to even figure out whether whatever piece of code he wrote will work with the other code that's already there in the repository. So there should be a mechanism that the source code management should tell him whether there's a clash with other code or it's okay to actually commit. So that's precisely what Git does. If there is a merge conflict, it will tell you that there is something wrong in your code which conflicts with certain line number and that guy's code. So you better go and find out and resolve the conflicts and then commit the solution. So, Git is essentially very powerful that way. I'm sure GitHub and GitLab predominantly follow the same rules, and they are as popular. So once we have the distributed source code management in place, there are other tools that we need to get. So we'll go to the next tool. I will show you a demonstration of the source code management using Git that we have for an organization. Now, once we are done with the source code management, which means that we have all the source code in one place. Now we need to take it, test it, and then deploy it. Now there are tools for each of all of this. It also depends on which technology you're using, because sometimes there are people who develop only the user interface. Then there are teams that develop only the business logic. So these two technologies have slightly different testing and other tasks that you need to do. So we will cover both. What we will do is we will see how, in case of business logic, what do we do, and in case of developing user interface, what is that we do different. So both of these we will take a look. So with this, and let me go to the next slide. Now, once you have the source code control in place, you need an automation server to automate all your tasks. See, this is the heart and soul of a continuous integration or a continuous deployment system. Most regression stuff, that is things that happen over and over and over again, you will need automation service. So the most popular is Jenkins. Jenkins is plug and play. Once you install Jenkins, there's practically a lot of plugins for doing practically whatever you want to do, whatever you want to automate. You want to sniff something, there is a plugin. You want to deploy something on a server, there's a plugin. You want to check if something on the operating system, there's a plugin. And practically plugins for every technology that ever is there on the cloud. There is a Jenkins plugin to do something on the technology. The second one is something similar, but slightly much lesser in use, is Concourse CI. And the third one is Atlassian Bamboo. The Atlassian is a company, and Concourse is also a company. Atlassian has got a product called Bamboo. But however, we will, in the course of this presentation, we will stick to Jenkins because we have a demo on the Jenkins server, which is widely available, is at no cost. It's practically free except for the server that you run it on. And it allows you to plug and play, except that you just need to know your way inside, and you can achieve, do wonders with that server. So once you have the the source code control in place, and you have the this one in place, the automation server, certain cases for certain tasks that you need to run, you will need a task runner. Okay, a task runner is an application that you install on the server, which Jenkins will call and give it some commands so that those commands can be run on the server. Now, the most popular of the task runners is Apache Ant. An Ant Ant actually stands for a neat tool. It practically is that because it can do anything and everything. It can move from one file from one directory to another directory. It can deploy your application. It can log into another server. It can take things from your source code control and deploy it. It can stop and start web servers. It can shut down databases and restart it again. It's practically the Swiss Army knife in this whole thing. And most projects use Ant as the task runner. But some projects, typically those that run on Node.js like Angular and things like that, they use a task runner called Gulp. And there is a competition with another tool called Grunt. So there is a set of people who say Gulp is the task runner. And then there's another set of people who say Grunt is the task runner, then all of us should use it. But okay, if you ask me, I would prefer Ant. But there are a lot of people who go with either Gulp or Grunt. Then there is yet another category of people who say that the Node.js supplies its own task runner called Yarn. So you should be using Yarn because it comes natively built into Node. So we will leave them with that, whether whatever they want to use, they can use. But for our demos, we will be using Ant. You may not be able to see Ant, but you can see how it actually runs the tasks. Okay, because Ant itself will not be visible. So you can see how it actually runs the tasks. So now we have the source code repository. You have an automation server. The automation server then actually links to the task runner. So basically what happens, you configure your jobs or your CICD jobs in the automation server. The automation server triggers the task runners to do a lot of things. This is essentially how the whole thing works. So finally, what happens is, in certain cases, especially in large deployments, when I say large deployments, I'm talking about 1,500 deploys a week. That's almost one deployment every 5 minutes. Yes, it is not shocking because there are e-commerce sites which do deployment every 5 minutes. You will need so many builds, and practically the Jenkins server will be triggering builds on multiple servers across the world, and they'll be deploying continuously. Every 5 minutes, you'll find a deploy, and 1,500 deploys a week is not at all strange, and a lot of people are doing it with the stack that I'm going to show you after I finish the presentation. So what they do is they add another piece to the whole thing. They use this one called containerization called Docker. Mainly Docker. Some people use the Linux containers called LXC, and some others use Apache Mesos. But predominantly, you will see Docker, containers being spun and created and then destroyed very often wherever the wherever the deploys are very high. I'm talking about 1 every minute or 1 every 5 minutes, or the CICD running on multiple servers. Now, why would I want to run a job on multiple servers? Let's say you have one source code but then you need to change the configurations, one for Europe, one for North America, one for Asia, and one for Australia. You simply give the jobs to the respective servers in the respective data centers. It automatically goes and finishes the job and gets it deployed. But when you do when you do a deployment every 5 minutes, you can't keep creating servers and destroying it. So what people normally do is they create a Docker image, and Docker is architected in such a way that you can actually create a container and destroy a container within a few seconds using the image. So high deploys, Docker is essentially an essential component in your entire stack. But if you have, let's say, a reasonably, not a very busy pipeline, let's say one deployment a day, then you don't need Docker. You might as well create the server and destroy it, which is what we will see. But if you have very high traffic deployments or high velocity deployments, then Docker is an essential piece in your entire architecture. So that we will, that's for orchestration. And then you will also need something to manage the configuration of your these servers. Now, for example, one of the biggest problems in software engineering from time immemorial is that every time you set up a machine and bring it onto your network, you find that the operating system version or the web server version or the database version is different from what was there in the previous instance. Now, there are tools, so one of which we will see, to actually ensure that the configuration that you get for machines any number of times that you deploy is exactly the same like the one that you created in the first machine. That is, you will have the same operating system, same version of, let's say, Apache or Nginx, same version of MySQL or MariaDB, same version of PHP, and so on and so forth. So the most popular of these configuration management tools is Ansible, okay, and some of these are priced. Then we have Chef, then we have the VMware Salt Stack, we have Fabric and Puppet. The one thing that I've not mentioned here, but is just becoming popular, is Terraform, and that is a demo we'll be seeing. So these are for configuring your servers. Now, why would I want to configure a server? Just imagine I have a very popular e-commerce platform, and I want to actually do a Diwali sale. Now, I might be running the platform with only about 10 servers, and then during the Diwali sale, the traffic is so high that I need to deploy another 10 servers. Now, that time I cannot clamor and go and try to figure out what was the version numbers of the OS web server that I did in the first case, which probably could be last year, and then try to recreate the same thing now, 12 months later. So instead of that, there are tools like the one, like all that's listed on this slide, where you can say that I want a machine which this is the plan, please create a machine for me, and it will create that in about few seconds. So once you do that, what happens? You can actually write a script to check the load on each of the servers that you already have deployed. So let's say 10 servers are fully loaded. You see that the traffic is coming. Your network monitoring tool indicates that you've got traffic coming in. So it automatically triggers the deployment of the 11th server. And once the traffic, again, even that has got the capacity utilized, it can deploy the 12th server. So this is essentially the pipeline that we're talking about since the first slide. Whatever happens, the moment you start deploying the code till about it hits production and is used by the server is completely automatic. There is absolutely no manual intervention except when people commit the code. And if there are errors in this pipeline, it wouldn't deploy it, or the code will not reach the user. So that is the idea. Now, what are the advantages of this? Yeah, bad code never reaches the customer. And even if it does, it will happen only one time, because the moment it's kind of triggered, caught either in during the automated testing, or even if it reached the customer and the customer reports it, people will people or the software engineers will automatically go fix the code, write a test case so that it never happens again. So over a period of time, as people get used to CI and CD, the code becomes better and better, the quality improves, and sometimes at one point it becomes practically error-free. So you'll never find bugs. All bugs will be caught either in during the automated testing. Never gets into deployment at all. So we will see what happens. I will show you a case where it successfully deploys and a case where it fails. So that is about configuration management. And now what I'm going to show you in the this one, that is the demonstration is, so we have this AB suite. We had it on BPM, which is a business process management platform. Then it so happened that it was not scaling up. So it would scale to, let us say, a few thousand users, but it was not really, scaling up to a few million users. So then what happened was the new architectural designs were actually formulated by a few scientists in the US called 12-factor applications. I mean, anybody's interested can always look it up on Google. 12-factor applications means that you architect your application in such a way that each individual component can scale on its own server automatically. That's one of the traits. But there are other traits. Yeah, you should be deployed without any hassles, and it should have gone through a CICD, and then you need to configure it in the command line. There's several. There are about 12 factors for it to be called 12-factor applications. So we wanted to move towards a 12-factor architecture. So we chose that our business logic should be developed in PHP, and we chose AngularJS for our user interface. Now, if you want to do in PHP, that is, if you want to do your applications in PHP, which is 12-factor compliant, and once you do 12-factor application compliant, it automatically becomes microservice-based application. So you will need certain tool set. That is, you need PHP unit so that you can run your PHP unit tests, and you can also run functional tests. So the example I'm going to show you, the demonstration I'm going to show you, will be using PHP unit to run the functional tests. And it will also generate the code coverage reports. It will tell you how much portion of your code has been covered by test cases. So you will know what risk you're taking in deploying it. Then we also have something called a PHP code sniffer. See, we will have a team which actually commits. Not all the people follow the standards PSR 15 for writing and naming variables. So we have a code sniffer to actually pick up all that and tell that, look, you're not complied with this naming conventions and so on and so forth. It's one of the biggest problems because people start naming variables as A, B, Z, student as S, officer as O. I mean, if you have variable names like that, it's very difficult for the guy who maintains it to even figure out what it contains. So we have a PHP code sniffer. So we will run that to check the sniffing, and we'll sniff the code. And then we also need to check if anyone has written variables that they don't release so that it takes all the memory in the server. See, one of the things in the cloud is that each script is given an amount of memory. So we set our scripts to take only about 32 MB of memory, okay, for the script on the server. Because if I allow it to take more, then it practically doesn't allow any other programs to run. So we have a profiling tool that will check if the scripts are taking too much of memory or which script is likely to take a lot of memory. So essentially what we do for our functional applications, we do a functional test, we sniff for coding standards, and also check if there's anything that consumes a lot of memory. We do those three. Coming to our user interface. Now, user interface has got two things. I mean, essential. One, of course, it has to look very pleasing to the end user. Apart from that, one of the things that it shouldn't do is the user interface should not actually collide with any other applications on the browser. One of the biggest problems that we have faced is, especially in the previous case, is that every time we make a presentation like this, that's online, we used to use a Zoom then, that the index of AngularJS and the index of Zoom used to clash. So our user interface during our presentations would go all haywire. The boxes will come somewhere else, because while Zoom was actually kind of transmitting, it would try to move elements around, and it would actually clash with the elements that we were tracing and things like that. But of course, we have solved that problem by migrating our application to the subsequent versions of AngularJS. So to check all that and to check whether we are able to pass data from the user interface into the the backend functional code, we use Jasmine, which is it is a testing framework for JavaScript. We use Karma, which is a task runner. It will run things in a browser. See, one of the things is in a user interface test, you don't have to see the browser to check. You can check that whether the elements are placed properly by using the program itself. So what we do is Karma actually will invoke the browsers, Chrome and let's say Firefox. Both of it will invoke in the memory. You will not, because the server does not have any display attached to it. So the browsers are invoked headless. That is, you don't see the UI, but it will be there in memory, in a place in memory. And you can go and check if your screen coordinates there. And let's say you want to have a pagination. You want the pagination to, you have programmed it in such a way that the pagination should come in the rightmost bottom corner. You can go and check. It will tell you whether it is there or not. If it is not there, that means your test is failing. So you can also check if there are 30 records that have been displayed and so on. Whatever you can do by seeing the browser, we can do it programmatically using Karma. Protractor is used for end-to-end tests, which is functional tests. You can test like how the user is actually testing by keying in data. So we use Protractor also. And then what we do is we minify the entire code. That is, see what happens in cloud applications is you try to keep the payload from the web server to the browser as small as possible. Okay, so to do that, what we do is all JavaScript and CSS, we minify so that they don't have any spaces. And when it comes to the browser, it automatically expanded and then read by the browser and rendered on the for the user. So this is what we do in the Angular. Predominantly, any other technology also will do more or less the same thing. Okay, let's say on the front end, if you use instead of AngularJS, if you're going to use let us say React.js or anything else, you will use predominantly the same set of tools. However, on the functional side, if you're not using PHP, if you're using Python or Perl or Ruby, those languages have got a different set of tools that you might have to use. But essentially, what you need to accomplish is exactly the same thing: a functional test, code sniff, and profiling. Only in this one, in the front end, you will need to minify your script before you actually deploy it, so that the payload is much lesser. So with that, I come to my demonstration. So what I'm doing right now is, I'm sitting in Chennai. Now I'm actually having my entire source code control, which is indicated by this red Git symbol in the Bangalore data center on the cloud. I also have my Jenkins on the data center on the cloud. Phase 2, we're planning to have the entire thing run on multiple data centers depending on the customers we receive. So we'll not worry about phase 2. But what we're planning to do in this is we're planning to take this code here and then test it, phase 1. And phase 1 meaning demo 1. Demo 2 is to also show you how to actually spin more and more servers. It's got nothing to do with the terms of actually, that is purely DevOps. The CICD involves picking up the source code, testing it, and deploying it, which is what we'll see in the first demo with using Git, Jenkins, and PHP unit and things like that. The second demo is a pure DevOps demo, which just increases just deploys a server and installs the infrastructure on. I've taken Amsterdam to save some time because we have a lot of servers in Amsterdam. Nobody seems to be using there. I usually show it on New York's center, but New York center is too much of traffic there. So I'd like to be a bit good and say, okay, I don't want to disturb you people, so I'm moving to Amsterdam. So this is what the demo will contain. So what is the workflow that I'm going to show you? Developers push code. Yeah, but I'm not going to push any code. I'm just going to run it. It will go into Git. I will show you the Git that we have hosted for the last 12 years. It's on the cloud. A lot of people are very concerned about security. This is a proof that there's nothing. I've stored the entire family jewels on the cloud, and so far, so good. Nothing has happened for the last 12 years. So what Jenkins does, it polls Git, it checks if any code has been committed, and it does that in the night when there's absolutely no traffic, all developers are asleep. It drops a database, it creates a database, it creates a schema, it does code compliance checks, runs all the tests, start to finish, again and once. It doesn't start from where it left off. Then it deploys the application and it publishes the report. This is for the backend. For the front end, what it does, of course, the front end workflow that I'm going to show you is a workflow that actually fails because during the minification, it actually fails. We created the error to show that it doesn't deploy when it fails. But the functional flows goes through. Okay, so we'll see that first. So with this, I will go to my demonstration. So what I'll do is, you can see the screen. Can someone confirm? Because I've switched from presentation to the browser.
Yes, sir, we can see.
Yeah, fabulous. Okay, this is my list of projects that I have on the cloud in the Git. So I'm going to show you a small AB caps, which is one of the modules. And you can see that we have a lot of commits. Okay, the last was on August 2, 2021. And most of the commits were done by me in this project. So this is one of the projects that we're going to see. The other one is even more interesting, which is the one that is going to come out of our release. The first is this AB compliance UI. Here, if you see, there are a lot of comments from several developers. You can see AK, Krish, Gautam, myself included, are all committing. And if you see the graph, you can see how the people have committed from which branch to which branch. This chap, some funny chap, has branched out here, did something. He has not even bothered to, after so many commits by others, he's actually merged the branch somewhere here. Okay, but that doesn't really matter to us because it's the developer's freedom. So these are the two projects that we're going to see. This project that you see, the developers have actually not followed the coding standards. This project will fail. That project will succeed. So with that, what I do is I'll go to my Jenkins server. So I'm going to log in as Sridhar and with my password. So you can see these are my projects, and these are all the projects that keep running. If you see that these are all run for the 1 month back, but this AB compliance UI ran about 3 days back, and it just took 2.7 seconds to do it. So what I'll do is I'll show you AB caps, not for any reason, but because it kind of finishes fast and we can use time available to discuss if you have any queries. So I'm going into the blue indicates that this one is success. This one indicates that no build has happened. The red one indicates it's all failed. There's also a black one for being aborted. I'll show you that as well. So let's go to AB caps. So you can see the code coverage reports here. It basically shows that 68.2% of the methods are tested, 30% of the statements are tested, Overall, only about close to 40% of this has been tested. The rest 40% we need to test. You can see the last few builds are successful. So let me see what happened in build 14. If you see that there were no changes, this has been triggered by me, started by you. Let's see how it does automatically. If I go back to the project, let's see the 13. If it is, this also was started by me. Okay. Let's see 12. This was started by Gautam. That's also no deal. 11. Something should be automatic. Yeah, you see this. This was not started by any of the user. It was started automatically because somebody pushed committed code in the this one. Now, so what do we do? How does it happen? So we have a set of instructions. So let me show you how we configure it. So if I should go to the configuration, okay, this is the configuration page of the job. So basically, I tell it from where to get these source code. I tell the Jenkins plugin, log into this server with this IP, go through this port, use my SSH key so that you'll be authenticated. We do not allow people to log into the command line without a 128-bit SSH key, and then pick up this particular repository, AB caps, the one that I showed you on the GUI here. This is the one, AB caps AP. So this is also AB caps AP. Now, once it does that, I tell it, see, the people can check in multiple branches. We only build the master branch because sometimes what happens, some specific client says you do something specific for, let's say, the Middle East or something for the Far East. Unless though we might actually do it once, we don't want to build it over and over again. So this actually, I should say, gives you tremendous amount of power because you can have multiple versions of the software for different continents, and within that you can have multiple other versions as branches, and you can build any branch that you want just by creating a new job. So that's what it is, and we also give it the URL. Okay, then what we do is we give it a build. What is the trigger to actually start the build? We tell it you keep on checking the source code management system and check once closer to, when I say HH, it automatically close to midnight. When it is not doing anything else, it will check. You can also say 00, it will do it exactly on midnight. But I would like to give Jenkins the flexibility to see if there is any job that is extended beyond its scheduled runtime, so that if it encounters this, it will stop this. It wouldn't run this till that gets finished. So that's why we've done HH. You can also do 00. Then what we do, how do we build? I say first thing is you create the same environment that was used for developing. So I install Composer. I drop the database. I force the drop. If any problem is there, I just say force the database drop. So it cleans anything that was there in the previous build. And then I ask it to create the database. And if you observe here, I'm not creating it directly. I'm creating it to the PHP object relationship manager called Doctrine. The same way that users actually created it when they developed it. And then after that happens, I said create the schema, which means all the tables will get created. Then I ask it to run the PHP code sniffer. But then even though this fails, I'm not really worried because even if it fails, it's not that the code is bad. It's only that code is not following standards. I say even just throw the errors, but pass this test. That's why this is true. If you remove the true, it will fail. Most tests will fail there. And then I say, okay, you run the PHP unit, you run the entire, publish the coverage reports, and then check. We also run some statistics to see how many lines of code. And once that is there, I deploy it to a directory, okay, and then create the database, and then come out. We have stopped sending mails, though we say that we can send a mail. If these mails don't go because we have disabled the mail sending, but we then publish the code coverage reports. So let us see how this actually runs. I will trigger this for you. So we are going to AB caps. So all I have to do is see, please watch the bottom build history. We are number 14 here. You will see that it will start number 15. It has started. So let us see what it is doing. I will see the console output. You can see what is happening. I'm going to actually make the browser a bit bigger so that you all can see it. Can you see? This is that PHP sniffer, code sniffer. So it has gone down. So it's running the tests now. You can see that it's finished the test. It's testing now. Okay. Finished. So you see, it has become finished success. Can you see it? Anybody who's not able to see this, the one I've highlighted? Okay, so what I'm going to do now, I'm going to come out of this project and I'm going to show you a project that has failed or will fail rather right in front of your eyes. So let's run the AngularJS project and see why that will fail very fast. So we're going here. So it's already failed. So that's what we're going to do. Make it fail once again. So let me increase this a bit so that I can, because it runs in only 2 seconds. So I do a build. Okay, I would like to show you the configuration. So if I go to the configuration here, you will see that it's slightly different, but essentially it's more or less the same. So source code management again goes to a specific folder. So if you go to that folder, it will be a different project. You see that? AB compliance UI Git. Okay. And if you come down, the build trigger again pull the source code management. Build environment is not there. Now, if you see what I'm doing is just, these are all just mechanisms to see whether it is running. I'm asking it to check which version of Google it's using, which version of Firefox is going to use, because I can't see the browser. It only runs it in memory. So I ask it to print which version it has. So it will print the version for me. And then it runs it installs the entire dependencies. And then it does a pre-run of, I've written a small script to pull in some libraries. That's why pre-end-to-end test, because this has to run before the end-to-end test start. And once it is done, it does a build here. ng build. Okay, ng is AngularJS's own build command. So they have written one. We don't need to use anything like gulp or crunch, which I told you earlier. We've stopped running the unit tests because we find that there's no point in testing units in Angular, because it all involves only placement of images, which apparently you can place it wherever we want. So we are going to do only the end-to-end functional test. That's why I've just commented it by saying echo it rather than do anything. And then I'm doing the linting. Linting means removing all the unnecessary white spaces. And this is the portion where it will fail, okay, because the lint will fail. And after that, I'm running the ng E2E, okay. And once that is there, I'm going to deploy it. But since this project will fail, the deployment will not happen. So once this deployment doesn't happen, we'll go to the DevOps side and see how we can actually deploy using the, running Terraform. Terraform is a DevOps tool where you can create a server and deploy it in multiple servers at the same time. But we will do that after we do this. What I've not showed you in my last job that I ran, see, when we ran the PHP unit, I'm supposed to have showed you that it has deployed AB caps. It is not. I'm sorry I didn't do that. So I'm just showing it to you now. This is the URL. So this is the quality of the software that it does. It builds everything microservices and 12-factor application complied. You can see that this is a small project. If you see, it takes all the HTTP verbs. Of course, I need to disable some of these. So you can create, this is AB caps. There are others. We deploy around 10. So I'll show you the others, which we've not built, but was built probably yesterday or day before. So the entire lending suite, it builds on a day-to-day, everyday basis. I don't have to wait at the end of the project to integrate and test. It builds daily. If somebody pushes one piece of code, it will test the entire thing from start to finish. So essentially, meaning at any point in time, if I have market competition, I can just create a version and announce it. That's the idea. So this is what is deployed. So now let's go back to our job here and execute something that fails. So I'm going here. Well, I can't even find it. So I can't even see where it is gone and done that. Okay, I need to minimize it so I can see the job now. Okay, it's there in the configuration. So I'm going here. So what I'll do is I'll have to build it now. I'm going to increase the size again so that you can see. So I'm going to build now, build a schedule. So we have 21, it's already finished. Oh, no, 22, okay. This is the one, it's building, it'll fail now. What is console output? There you go. So it is running, it's now doing that npm install command that you saw. And so it's building now. If you see the ng build command is triggered, it also tells me that there's a mismatch in my global Angular's version. So you see that it has taken the correct version of AngularJS. See, the local Angular CLI version is used. So to that extent, it maintains the test bed to be the same across all your builds. So it's compiling the ECMAScript for Angular, and now it will try and run the this one. See, normally we run the E2E tests and then run the minification, but for the test to fail, I move the minification before the tests. Yeah, I think we're almost there. Once it finishes the build, it will run the this one, the what is it? It tries to compress the AngularJS. So that's when it tries to minify it, and then it fails because a lot of semicolons are knocked off, so that it will fail. Yeah, there you go. So it's generating the browser application. The application actually is ready, but without the test run. So, but yeah, I moved the minification before the test so that it is that the job fails. Okay, while it does this, I think we should look at the DevOps side of it. We'll come back to this. We'll not close this. So, assuming that it is going on till it fails, we need not wait. So, the other thing I wanted to actually touch upon is the DevOps side of it. Now, let's say we have this, it's going through, everything will be done. Okay. Okay, I'll get my other stuff ready so that while it does, I can actually. Okay, so while it generates, I'm logging into my cloud console. So we use DigitalOcean. And this is for the DevOps portion of it. So what I'm going to do is I'm going to log in. And I can't even see a login. Yeah, there you go. And it's supposed to send me a 6-digit code. So I'm checking my phone to actually get that 6-digit code. I'm actually checking Gmail. So yeah, I seem to have got it. So 84437. Okay, I've got the code. I'm going in. So it's allowed me. Now, let's see what's happened to our job. Yeah, it's linting now, so it should fail now. So let it continue. So basically, this is my cloud console for DigitalOcean. Of course, it could have been any console. It could be in AWS, a Google Compute platform. Now, why I'm showing you this is if you see the total number of servers that I have, I can't use, this is the list. I would have about 7 or 8 servers, 3, 6, 7. Now I'm going to get the 8th server, okay? Now, what I'm going to do is I can do a create server here, but I don't want to do that. I'm trying to be a little more techie. So I'll go here. Now, I have something called Terraform. Now, what Terraform does is it allows me to actually create the same server either on DigitalOcean, AWS, or on GCP. Same configuration and anywhere in the world. So what I'm planning to do is now I'm going to give it a configuration and say you create it on DigitalOcean. So what is the configuration? So how do I specify the configuration? I do it here. Can you see the screen? Because we have not checked if this is visible. Are you able to see this?
Yes, sir.
Okay, fabulous. Now, basically what I'm telling is I've just given it a name, okay, and then say I want this specific operating system image, the one that you see here. I'm highlighting it for you. So I want Ubuntu 20 64-bit architecture. I'm going to call my server ABComp UI1. I want it in Amsterdam Data Center 3. I can choose it anywhere in the world. I'm just choosing it in a continent. I can choose US as well, but US data centers are usually busy, so I normally don't deploy anything there. And I want one virtual CPU with 2 GB. So that small I can create. I can create hundreds of it at the same time, but we'll be a bit modest and create only one. So I'm creating only one. And I'm going to internally network it with, I need to have private networking. And what I'm telling is this is the DigitalOcean key that it has to check. And what I've done is I've stored the DigitalOcean key on my OS itself. Okay. And what I did is I'm asking it to connect using the IPv4 instead of IPv6 address and log in using root and SSH. And I have given the private key, okay, that is my SSH key, so that there can be an handshake between the DigitalOcean API and this. And I ask it to wait just for about 2 minutes. After that, it will come out. And then I ask it to update, install Nginx, and install Git. That is it. So after we do this, we deploy it. We will see how it shows us the welcome page of Nginx by taking the IP address. So once I do this, I run. The plan is generated. To save some time, I just generated the plan at about 2 o'clock this afternoon. And this is what it did. So I saved this page. So what it does is once I do that, I run this command. So I say apply the plan and generate an infra.out command. Okay, so it basically created this for me. So the previous build was incorrect, so it destroyed that. And it has connected via SSH, it's created all that. And finally, it has come to, it has created all of this and finally finished the job. And it has created this file called infra.out. So what I need to do is I just need to apply this infra.out, okay, to my DigitalOcean API, and the whole thing is created. So let me see this. So what happens is I just run it, it will run the same things again. So if you see here, okay, let's create another plan, no problem. It's already, I'll remove this infra.out. Okay, and I will run this again. So just, okay, so it will start. I'm giving my private key. So let's see what it does. Okay, it's already done it. So let's apply it. Creating. The droplet is creating. So while it creates, so let's see what happened to our AngularJS job. It should have failed by now. That failed. Do you see it here? Can people see? Anybody confirm, please?
Yes, sir.
Yes, please, Priya. Finished failure, yes.
Finish failure, because this will not get deployed on the server. It will never reach the user. Still, developers go and fix. So, what are the errors that it has figured out? Expected one space is not good. Missing white space. Trailing names is not available. Plenty semicolons not available. It has checked everything, and when you see somewhere another semicolon missing. Okay. So this is the amount of control that you can have over your, pipeline. So I would encourage all of you to look at implementing it in your respective projects. So this I will log out. We'll go back to our Terraform. So I'll log out from here and go to this. So we have still 3, 4, 5, 6, 7. So let us see what happened to our job here. Oh, it's okay. Something didn't go through. Okay, let's run it again. Okay, I'll remove it. So I have to do okay. I don't know why it has exited. It doesn't seem to be like. Okay, so I'm applying it again. So if you see, I've not changed much of this code except that I'm only basing the entire this one. So it's trying to destroy. So something has been left in half. So it will destroy that and start. So let's see what happens. And so while it is doing, I think I'll open the. I'll answer the questions that I received in the registration. So Mr. Chandamauli wanted to know what is the latest tech stack of CICD. Yeah, this is subjective. It depends on what technology you're using to develop your applications. If you're developing PHP and AngularJS, I've covered it in the presentation. But if you're using Python or Ruby or something else, then I think, the tools will slightly differ. Not to a great extent, because Jenkins and Ant and all will stay the same, but your code sniffing tools will change, and so will the testing tools. You may not use PHP unit, you might use something else. Dr. Kavita from Sastra University wants to know what is the scope of DevOps and what are its demands. Okay, the scope of DevOps is very clear. Given a code, it will be, compiled, checked, built, and deployed without any human intervention. And then, I think there is something funny because it's created this server, but it's not able to get a lock on it. So let me see if it has actually done that. So I can remove it later. So hopefully, maybe the install has failed on the server, but it did run at 2 o'clock. So let's see at least if this, it has created the server. What has failed is it's trying to execute this one. So let's see what it has created this. So let me copy this API and see if it has installed Nginx. Yeah. So basically what has happened is it's trying to execute the remote jobs. It's not able to deploy that. So why, I do not know. Maybe the API is not giving it permission, or it is very, busy. We don't know. So the provisioner remote execution process has failed with some status 100. So anyway, but I really don't know why it should do this, because it was running all these days. So maybe there's a problem with that data center. But it will run. Terraform will run on anywhere. So what you can do is you can actually link Terraform to the build process, and things will get deployed automatically. That is the idea. So yeah, this actually didn't do that. But ideally, but it has gone and created the server. And where it has not done is that it has actually gone and it should have installed Nginx automatically, which it didn't. But it did create the server. This server was not there before. So that is. Now, coming back to the questions I've received, Sendil Kumar from JSWAT has said, how to adopt and enforce CICD. See, we can't enforce CICD. It has to come from the developer. Encouragement and training are the best way. Any brute force mechanisms is likely to actually backfire because, the first thing people think is if every testing and all is done by a machine, what happens to my job? Okay, so obviously you'll have to train people to move higher in the value chain, tell them that the jobs are not at stake, but that they have to compete with some of the best in the industry, and that's why this is being done. So I hope that answers your question. And Dr. Rajiv Tripathi of Ram Swarup Memorial College wants a relenting example. Yeah, I think my demo should have actually conveyed where it actually fits in. And it's practically every single piece of software that's delivered today uses some form of CI/CD altogether or DevOps together. Then Sivaraj of CAD graph diagram said, what are the current trends? Yeah, the current trends are 1500 deploys per week and above. That's the velocity of programming that's happening. So now you understand why people are able to come out with new fintech companies every month. It's practically because it's so easy to actually now develop. You don't need to have 100 testers to test your application. We have one set of test cases, we just apply it over and over again. So I have not seen more than 1500 deploys a week. Probably they are, beyond that. Okay. So then there is Shivangi Pandey from SSN College. What are the applications of CI and CD and DevOps in healthcare? Yeah, healthcare, it's very, very relevant to have very error-free code. So whether you put the code inside a device like ECG monitors or any scanning machines or radiological machines, the idea is to keep testing it so relentlessly that it passes every minute test that is possible. So it's extremely relevant where speed and accuracy is required. So what DevOps, CI and CD gives you is that it is fast and it is accurate. If you have any further questions, I can take it. Or
we have received a few questions from chat box also.
Sure.
Just I will read out the questions and you can give answers.
What I'll do is I'll come out of this so that and then we reduce this one so you can see my face. Just give me a second.
Is it possible to use Jenkins to run and train AI applications such as deep learning codes?
You can run, but what do you want to run it for? Because actually when you want, Jenkins is a task runner. So you tell it you run this application, it will go and run as long as that application to be run as an interface to Jenkins. See, Jenkins will not be able to communicate with other applications unless somebody develops this inter-application communication. So they write a plugin. So if you have a plugin and that plugin is able to communicate with the application, you can trigger it.
Okay, sir. Next question is, what is this Angular test?
Okay, Angular is a UI framework developed by Google. Okay, and is one of the most popular front-end development applications. Okay, and most people either use React.js or AngularJS. And that Angular test that I ran is for our front-end in the that is used in the AnyBank application. So what happened is that we failed that test so that it doesn't get deployed.
Is the source code getting optimized? If so, at what stage?
Yeah, the source code is definitely getting optimized at two stages. One is optimized for accuracy by running the code sniffer. And the second one is it's highly optimized when you run the profiler. It will check what amount of memory it uses. And if there is anything that can kind of breach the memory that you have set, we set 32 MB for each script. Because if you see, I ran the entire thing in about 2 GB machine. Okay, you can have any amount of memory, But to ensure that each script takes only 2 GB, you can enforce it in the profile.
Thank you very much, sir. These are the questions from chat box.
Yeah.
Now I request Dr. Priya Vijay, Chairman, Computer Society of India, Chennai chapter, to formally propose the vote of thanks.
Thank you, sir. Thank you so much. I thank you all for attending this webinar. I thank our speaker for his wonderful and informative, very informative webinar, which also has the demonstration, which is very helpful to clearly understand what CICD, DevOps, and how it can be implemented. I thank Mr. Sridhar Pandurangiah, Chief Technology Officer, Sastra Technologies, for his excellent webinar. I thank our associative partners, our partners and Chair, ACM Chennai Chapter, Mr. H.R. Mohan, and Chair, IEEE CS Madras, Dr. P. Sakthivel. I would also like to thank our event coordinators, Mr. P.V. Subramaniam, past Chair, and Dr. Agila, present MC member. I also want to thank all the past and present OB members and MC members of all 3 professional societies. I want to thank all our participants who enthusiastically participated and asked many questions also. I thank all the participants. Regarding upcoming webinars, what we are conducting a symposium on intelligent and smart systems. We are calling for papers. The details has been sent through mail. And we are having a webinar beyond ERP's next-gen technologies on 11th September. And webinar on applications of machine learning in life sciences on 25th September. The invite link has also posted in chat. I invite you all to attend our upcoming webinars. Thank you all for attending the webinar. Thank you all. Good night. Take care. Be safe. Thank you all.
Thank you.
Once again, thank you, sir. Thank you very much.
Thank you very much. Thank you.
Now you can sign out, sir.
Right. Thank you very much. Bye-bye.
Thank you, sir. Thank you.
The recording can be stopped.
Stops. Okay, sir.
Okay, thanks, Dr. Sakthivel.
Thank you, sir. Thank you very much, sir. Okay.